And so this signaling requirement is for the receiver. The sender also has a signaling requirement. Remember the requirement 2 the sender also has a signaling requirement 2. So remember that requirement 2 concerns all players. Requirement 1 also concerns all players, but the sender's requirement is quite trivial. So requirement 2 for the sender is that for each type Ti in the set of types T that nature draws, the sender's message M star Ti, the message that they send given the type Ti that nature draws and they observe, must maximize the sender's utility. Given the receiver's strategy A star, given that the message that there is, which is a function of the message that they receive from the sender. So this means that M star, the message that the sender receives given that the type that nature draws, solves the maximization problem for all messages in the set of messages M of the utility. So it has to solve this maximization, which is basically it must maximize the message that the sender receives, must maximize the sender's utility, which is a function of the sender's type Ti, the message that they send Mj, and the receiver's actions given that the message that they receive from the sender. So what this means is that the sender's strategy must be optimal given the receiver's strategy. And the final requirement for perfect Bayesian equilibrium, requirement 3, states that for each message Mj in the set of messages M, if there exists a type Ti in the set of types T such that the message sent by the sender given the type that nature draws is equal to Mj, the receiver's belief at that information set corresponds, that information set corresponding to the message sent Mj must follow from Bayes' rule. Okay, so for each message Mj in the information set M, if there exists a type Ti of sender in the set of types capital T, such that the message sent by the sender is Mj, the receiver's belief at that information set corresponding to Mj. So after the sender sends a message, the node that the receiver finds themselves in, the belief of the receiver at that node must follow from Bayes' rule. Okay? And the sender strategy okay? So the belief must follow from Bayes' rule and the sender strategy. So this belief, mu, of the sender's type Ti, given that the message that they sent Mj, must follow Bayes' rule, which is the probability that the sender is type Ti over the total, or the total sum of probabilities of types. So for all Ti's in the set of types T, that's the belief. So we can have a generic definition for example, and we can say that a pure strategy, perfect Bayesian equilibrium in a signaling game is a pair of strategies M star Ti, a message sent by the sender given the type that nature draws for them, and A star Mj, an action taken by the receiver given the message they received from the sender, and the belief mu Ti, a belief about the sender's type given that the message sent by the sender, satisfying the signaling requirements we highlighted above. So 1, 2R, 2S, and 3.